The sun affects life on Earth in many ways. Sunlight provides the energy that makes our planet livable, but the sun is also the source of disturbances in space that can have an effect on our everyday life. These disturbances are caused by solar storms. Our sun is not a quiet place. When we observe it in ultraviolet light, as you can see on the video playing on the screen above, we see many things happening at the sun's surface. And in particular, the most violent events that are observed there and that appear as bright flashes of light on the video are solar eruptions. And during those eruptions, giant clouds of solar particles are ejected into space. These clouds of solar particles are the solar storms. After they erupt from the sun's surface, these clouds of solar particles expand into space and propagate in our solar system. They can interact with all the planets when they are in their way. In the case of Earth, we are relatively well protected from these solar storms because the Earth's magnetic field creates a natural shield around our planet. However, the solar storms which arrive here from the left of the video can breach the Earth's magnetic shield through a process that is called magnetic reconnection and which opens the Earth's magnetic field. This allows particles from the solar storm to enter in the Earth's magnetic field, where they are accelerated and channeled towards the Earth's polar regions. And when these fast solar particles hit our atmosphere near the pole, and in particular hit the oxygen in our atmosphere, that is what creates the northern lights. Many of you here living in Finland are probably familiar with the northern lights, these dancing curtains of mostly green, but also red and purple that dance in the sky at above 100 kilometers above our heads. So solar storms have very nice consequences on Earth because they create these beautiful light displays in the sky. However, northern lights are not the only consequences of solar storms, and the other ones are not as beautiful. Solar storms can also have damaging effects on human technologies, both in space and on the ground. In space, solar storms can, for example, damage spacecraft electronics, disrupt GPS telecommunications, or even endanger astronauts when they're outside of the space station. And in the case of the most violent storms, for example, one that took place in March 1989, we observe also damages to the power grid on Earth. The picture here on the screen shows a transformer in Quebec that was badly damaged after the storm from 1989. And this actually caused a large-scale power outage in this province of Canada that lasted for 9 hours. So because of these very bad consequences of solar storms, we space physicists are trying to better understand how the solar storms affect our near-Earth space. In my research, I focus on one specific aspect of these effects of solar storms, and that's how they affect waves that are created ahead of the Earth's magnetic field. To study those waves, I use computer models that we develop at the University of Helsinki, and that show us a global view of the processes happening in near-Earth space. That's what is shown on the purple pictures there. And in addition to computer models, another way I use to study near-Earth space is using measurements from scientific spacecraft that are in orbit around Earth. And these spacecraft measurements are the other figures that are shown here in green, yellow. So the waves I'm studying are electromagnetic waves, so fluctuations of the magnetic field. It's not the kind of waves that our human ear can hear. However, if we could hear the magnetic song of near-Earth space, what would it sound like? Well, during quiet times, we would hear a sort of low, continuous note going something like mm. But then, when the solar storm hits, this song would change, and we would hear a higher-pitched tune with a lot of tremolo and vibrato in the note, going more something like da. But but I'm sure you'd rather hear the actual sound of those waves. So with a bit of magic, we transformed our spacecraft measurements into something that is audible by our human ears. So I'm going to play those sounds now, first with the quiet time waves, and then how they sound during the solar storm. So please enjoy the sounds of space. Thank you for your attention.
Thank you, Lucile. That's truly amazing. I immediately started to imagine that there has to be some hidden messages from the aliens or something between the lines. I must heard something, but yeah, I guess people react on those voices a bit differently. Before I ask you anything, I want to advertise a bit for you guys. There is a very interesting documentary film in Yle Areena right now about this topic. The film is called Revontulien armoilla. And the filmmakers actually interviewed Lucile's research team from the physics department when they were making this film. So if you want to know more about this subject, you could definitely go and check Revontulien armoilla from Yle Areena. Okay, but now I have some questions for you. Could you explain a bit more about how well we can predict the aurora or the solar storms at the moment? How long before we know if it's going to happen or not?
So basically, it's really hard to predict when a solar storm will erupt from the sun. So we start to have information that a solar storm is coming when it's erupted from the sun and starts propagating into space, which gives us some advance warning, which is generally from 1 to 4 days. But we are never completely sure of the trajectory the storm will take. So we are quite good at predicting that, mostly. And then there's a second phase of how strong the effects of the storm will be at Earth, which depends on the properties of the storm and which only know about an hour before it hits the Earth. So that gives us very little advance warning. People that watch the aurora, for example, follow observations from spacecraft that are about 1 hour ahead of Earth in space, so that they get information on if there's going to be a high chances of aurora in the next hour or not.
Okay, so if I want to go to the Lapland and see the northern lights, I cannot know, or can I know somehow?
So then there's more longer-term changes in the number of solar storms. So for example, at the moment, it's not the best time to go to Lapland to see auroras because we are in a period called solar minimum. So the activity of the sun, so the number of solar storms that are created, varies on a cycle that lasts about 11 years. And so in 5-6 years from now will be a much better time. There will be much more solar storms to create bright auroras. And then there's also good and better times of the year. For example, near the equinox is a better time to go watch the aurora. But you can also go to Lapland now and be lucky and see them, because there's still some auroras, even during a quiet period as now.
Yeah, let's not tell about the quiet period to all our tourists so that they will not wait until 11 years or so. Okay, good. In your presentation, you told us that the solar storms can also cause troubles and damages. So has there been very strong solar storms in the past? What do we know about the history?
So the first solar storm that was recorded was in the middle of the 19th century. So at the time, there were no satellites in space, there was no electricity, but it still caused some damages on the telegraph system. Some telegraph operators reported that there were signals even if the lines were disconnected and so on. So at the time, it didn't cause too many bad effects because technology wasn't as advanced as now. But that's the strongest example we have. More recently, so there was this storm in 1989, which was the strongest since we have spacecraft in space, and that caused this power outage in Quebec. There's also some interesting stories about another storm that took place during World War II. And there were, there was a supply ship that was supposed to travel in the dark of the night. But the aurora was so bright that it was visible, and one of the German U-boats saw that ship and sank it because of the light from the northern lights.
Okay, interesting. So even if we cannot predict when the strong storm will come, but what do we know about our satellites and other space technology if a huge storm would hit us? What can we protect the satellites and our internet connection somehow?
So some options are to basically shut down some of the satellites, put them on safe mode so that they are not damaged during the solar storms. However, with GPS, we cannot really do without GPS satellites for a long time. So there's also shielding that is studied to protect the spacecraft electronics. In the case of astronauts, for example, when a solar storm is coming, they don't go outside of the space station during those times so that they are protected. There's also flights that fly over the poles, so in areas that are quite vulnerable to particles from the solar storm. And there's been cases when some flights were rerouted to safer areas. So there's options to protect ourselves and our technology from the solar storms.
Okay, good. What needs to be researched next? What we don't know yet about these solar storms?
So one of the main challenges to better forecast those storms is having a means to predict when they will erupt. So people are working on probabilistic models, so trying to find what are the chances of having an eruption in the next 12 hours or 24 hours. And that's really a big challenge in the field right now.
Thank you, Lucile. Let's give a round of applause to Lucile. Thank you so much.